Hi, in this lesson, we're going to look at one approach of machine learning, supervised learning. First, let's review machine learning. Machine learning is the process of presenting a computer with input data, letting our chosen machine learning model learn from the data using a series of mathematical algorithms, testing the trained model to ensure success, then using the model to make informed decisions and insights about future inputs. There are three main types of machine learning algorithms that are most commonly used: supervised learning, unsupervised learning, and reinforcement learning. In this lesson, we're going to focus on supervised learning. With supervised learning algorithms, we act as the teacher or the supervisor in the learning process. In the training dataset, we provide the input data called data features, like images of cats and dogs, as well as the data labels. The labels are going to be what we want the model to be able to predict, and are ways that we as the supervisors provide context or meaning to the data. In this example, we want the model to be able to predict if an input image is a cat or a dog. As the machine learning model is going through its training process, it learns to associate the properties of certain images with the word cat and others with the word dog. In practice, we'll probably actually use numerical labels, like 0 and 1, but they serve the same purpose. When training and testing is complete, we can now send in a new image of a cat or a dog, and it will predict which one is present. Remember, the data could be anything, as long as we provide features and labels. For example, we could use a dataset of the Titanic passengers and build a model that would predict whether or not a passenger survives. Values in the training dataset like age, sex, class, and fare would be our data features, while the values that say whether or not the passenger survived are the data labels. Once trained and tested, we can now send in a new passenger's feature data, and the model will predict whether or not the passenger will survive. Remember back to your math and science classes when you plotted data on an XY coordinate plane, then drew a line of best fit to match the data. For example, maybe looking at the relationship between force and the acceleration of a car in a physics class. These are also examples of supervised learning, where the x-axis values, the applied force in this case, are the data features, and the y-axis values, the acceleration, are the labels. The line of best fit is the model that is trained by the data. With this model in place, if we're given a new x value, we can predict what its y value will be. As we can see, supervised learning algorithms are great when we want to make predictions and we have labeled data to train our models with. There are many interesting examples of supervised learning. Email spam filtering uses emails labeled as spam or not in order to predict if future emails should go to your inbox or spam folder. Banks can use past transactions that are labeled as fraudulent and legitimate in order to flag potentially suspicious activity. Image recognition systems can be trained to detect desired objects in images. For example, social media platforms and digital photo storage services will sometimes ask you to tag who are in your photos. Then, using this labeled data, they can predict when these same people appear in future photos. Medical imaging has also come a long way in being able to detect things like cancers, tumors, and diseases by training systems with labeled images. There are many examples, like in real estate, where we can use historical data around prices to predict future price outputs. These are just a few examples of the modern-day uses of supervised learning algorithms, and they are all dependent on having labeled data in order to make predictions. Some of the other learning models are helpful in other situations, and we will learn more about them in future lessons. For now, it's your turn to explore more about supervised learning.